check about the circuit sizing. How do we calculate our circuit size? How many microinverters are there, and what parameters do we consider that, right? So this is just an example. So the foundation building block of Enphase architecture is the branch circuit, because as you know that all our microinverters are connected in parallel using our in-house indigenous Q cable. Okay, so this Q cable is also called AC cable. So it is all AC, disconnected on your roof. Okay, so branch circuits are simply AC circuits consisting of a common AC bus wire tied into the electrical system, either directly to the main service electrical panel or to a common AC load center functioning as a AC box, or maybe a solar sub panel, whatever trend you have at your customer side, depending on the size. Okay, so Enphase name for main AC bus cable, as I told, we also call Q cable or AC cable, right? So as the inverter generates current, it is contributed onto the cable down the wire, and the current is backfed into the circuit breaker or in the service panel. So one of the primary design parameters of Enphase system is the simple understanding of how to calculate the maximum number of microinverters that can be accommodated on a single branch circuit. So if I consider this as one branch circuit, how to calculate that, how many microinverters can be there. Okay, so though this number is given here up to 12, okay, but to see how this number is coming up to 12 here, right? So we all know that this Q cable is basically 2.5 mm square cable, okay, the AC. So based on this, we know that the capacity of our Q cable is, what is the capacity here? It's basically the 20 amps. So if we see here, the OCPD which is required for this Q cable is of 20 amps. Now, so we have to calculate the number of microinverters based on the capacity of our Q cable here. Okay, so we'll talk about single line diagram. We do have single line diagram where we can give you more detail of it, and then we'll calculate how this works. So let's see first the single line diagram so that we know that what all components are there in that, and then we'll see the calculation part. Yeah. So Hari, can you talk about a bit about India SLD and what all things we have, do we need?
Yeah, sure. Thank you. So the screen here shows you the typical wiring schematic single line diagram for a single phase system. Broadly, if you see each panel, this is a plug and play system. The installation is like once you install the panels on the roof, then the wiring is much simpler. So this drawing, if you see, each panel has a microinverter connected to the frame of the panel or to the structure just beside behind the panel. Okay, and the DC is connected. The DC polarity is connected to the DC terminals. You can see the top MC4 plus and male and female connectors, which comes from the panel positive and negative connectors. Okay, and then the Q cable, we have a Q cable, and this is Enphase patented cable. It has an AC bus cable. Okay, this is flexible. It directly parallels all the inverters. You can then use this cable to connect to each inverter as per the string sizing. And at the end, one end, we use the branch terminator to end the cable, and then directly you terminate it to a roof isolator. This junction box which is inverted is a roof isolator where you have an MCB, a breaker. This is for surge protection. Okay, and you feed the single phase from the grid, from the meter. So the single phase 2 wire will go to this MCB. Okay, and once the grid is given, so this based on the grid sensors it operates. So this is a simple our single line schematic. Okay, and in this junction box we have that NYS. The NYS is our monitoring device. So monitoring device, you don't need to connect any new cables for it. It just need to sense the power where your products producing. Okay. So this drawing is a three-phase schematic drawing. Okay. So you earlier you have a single phase. Similarly, here the number of panels will be higher in the three phase. So here, if you say I have 39 panels side, so 39 times 40 is close to a 10 kilowatt or 15 kilowatt side. Okay. So you split the panels appropriately to each phases. So here it is like 13, 13. So 13 is the higher size that we'll see at the later stage. Based on you can design the string sizes based on the site requirements also. So all the three phases you connect to an MCB, 4-pole MCB here. So 4-pole MCB where you feed the three-phase wire by using a 4-core wire. You feed the three-phase grid supply. Okay, and the NY you're using, the NY will sense the power from the three-phase, and based on it, it monitor the data, and you can see that in our web portal or mobile app and features like that. And next to NY, you can see a white box. This is a phase coupler. This is used for the communication of the NY. Okay, and rest, see after that, the generator, meter, and LT panel is the regular stuff which you already, the existing home or existing your commercial system where you are planning to do the installation, it already possesses that. Okay.
Okay. Thank you, Hari. So guys, just to remind you all, if you have any questions, please group, keep writing your questions in the question slot so that we'll take the questions at the end. Okay. So sometimes you forget what questions you need to ask because the topic is going and you have something relevant to that topic. So keep writing and we'll take all the questions. Thanks, Hari, for SLDs, single phase and three phase. Now, I think this is already there in one of the slides, but just want to make sure that because I still need to cover how you come up with this number, but just want to make sure that let's see how many of you have got that. So, this question is coming on your screen, and I want you guys to just quickly vote for it. Let me see. This is for IQ7 plus. So I've not mentioned here, but definitely on the question, they've already mentioned that what is the maximum number of IQ7 plus you can use one branch circuit. Okay, another 5 seconds. All right. So most of you got absolutely correct. So let's see how this number comes up. So we know that the IQ7 maximum we can have about 12 microinverters in one branch circuit. Okay. So let's see how we get this number. Okay. So in terms of IQ7, we have 12. In terms of IQ7A, which will be coming, we have 11 here. So let's see how these numbers comes up. So this is a simple calculation method. So first thing is you're going to calculate your circuit current calculation, or you can also get this value from your data sheet as well, right? You can calculate, or you can even get from your data sheet. Now after that, the second point here is, because we know that our branch circuit, one branch circuit is of 20 amps, because our Q cable is of 20 amps rating. Okay. So for 20 amps, what would be the maximum output current we can flow in that Q cable, keeping the safety factor percentage? So here, this 20 amp is multiplied by 0.75. Reason being, we have kept 25% as the safety factor. Okay, so that the fluctuations, overcurrent, all those parameters. So as a standard, we kept 25% because the grid is not too stable in India. So we have kept 25% for India. Okay, so 25% is safety factor. So that's why we multiplied this 20 amp branch circuit full current capacity to 0.75. So that will give us the maximum continuous output current we can load the Q cable. Okay, and then once we get that, we can divide that maximum continuous current by the current from one microinverter. You know that all our Q cables and microinverters, the help of Q cables connected in parallel, and so when we are connected in parallel, our current from each microinverter gets added up. Okay, so we'll divide our maximum continuous current on Q cable derived from above with the current per microinverter coming out of from one microinverter. That will give us the maximum number of microinverters. So let's take an example here for IQ7. Okay, so for IQ7, if we see, we know that the maximum continuous output power is 290. Okay, if you divide this 290 by 240, okay, you'll get 1.21. Or if you see the data sheets, by considering 230, you might get 1.26, right? So what, either you take 1.21 or 1.26, you'll get approximately the same value here. So the important is this part. So we know that the maximum current which we can load in our Q cable is 15 amps, keeping up 25% of the safety factor. Now this 15 amps is the maximum current capacity, continuous current capacity of our cable. Now this I'll divide with the current coming out from each microinverter. This will give me the number of microinverters I can have in one branch circuit. Okay, so that is just the limit of a branch circuit. You can have your different things and then you can connect, but this is the capacity of just one branch circuit. So we can have 12 microinverters. Okay, so this is the output from probably one branch circuit. For example, like you can multiply this 12 micros, right, with your total VA. This will give you the output. Okay, so that is the simple way of calculating how many microinverters you can have in one branch. Very, very straightforward. That's what we keep telling, that there is no high-tech design, there is no high-tech calculation required. Very straightforward plug-and-play system. Okay. All right. Now let's talk about a quick, when you design a little bigger system, right? So when you design a little bigger system, you need to take care of one more factor, which is called voltage.
पूरा करियल ना वायरिंग पेलन अब आजू वाला वायरिंग करियल તે શું છે રોપ કરિયાલ હા શું હો ગયા આવતો નહીં એમ કે છે આવતો નહીં ગોધી આવતો નહીં એમ કે છે એટલે એટલે નહીં કરી હાલતો એટલે નહીં કરી હાલતો બોલો ના નહીં મેર પડ્યો ના હવે એની માટે પછી હવે સિલેક્શન પછી એમાં જવું પડે બીજી બ્રાન્ડમાં. આ બ્લુ સ્ટાર છે, હવે પછી બીજી બ્રાન્ડમાં જઈએ, પણ એમાં આપણે જે જોઈએ છે ને એ તો નહીં, પેલામાં છે એસએસ માં. ના, ફાઈબરમાં નહીં, ફાઈબર વસ્તુ સારી એમ સમજો. હવે એસએસ માં હાલે છે તો એમાં થાય છે એવું કે આપણી જે સાઈઝ છે એ સાઈઝ પ્રમાણે નહીં આવતું. એક આવે છે 20 લીટર અને એક આવે છે 80 લીટર. એટલે બંને બાજુ તકલીફ છે ને એમાં પાછું હીટર નો ઓપ્શન નહીં. એ તમને ખાલી નળ એકલો જ આપે એસએસ માં. અત્યારે જે તમારું છે ને એવું ને એવું જ આવે. ફાઈબર નું મેર આ રીતનું ઓલ ઇન વન માં બીજી કંપની હું તપાસ કરાવડાવું. હા, એ તો ખબર જ છે, પણ હવે એમાં શું છે કે આ ફાઈબર ના ચાલે છે વધારે, એટલે આ લોકો આરા બનાવતા છે ને એવું છે. અને એસએસ માં ભાવ લેવા માટે શું છે, પાર્ટી એસએસ કરીને ભાવ લઈ લે. હા હા, તો તપાસ કરાવીને કહું તમને. હા ને, ઓકે. હા.
That what you can do, the best practice is that design what is the center fix system to do? Let's say on one branch you have 13 microinverters or 12 microinverters. Right? Let's say you are designed for IQ7 and one branch you have 12 microinverters. So when you from the data sheet or from the VRISE sheet, when you get the VRISE against 12 microinverters, that will be definitely high compared to when you do a center feed. The center feed will give you 6 on one side and then you have a center feed and 6 on the other side. So this is your center feed here. Okay. So this side you have 6, this side you have 6. So automatically the VRISE will be reduced because it will be only calculating for 6. Okay. So this gives you a lower VRISE. So whenever you have a bigger system and VRISE is going more than 2%, in that case, you should design with a center feed. And that is the best practice we should have in terms of if we are calculating the VRISE. Okay. Now, just based on understanding of in terms of Enphase, let's see what do you understand by this question, and please answer this. Let me see what do you understand. So it says, is it okay to install 15 amps breaker instead of 20 amps breaker? So remember the slide where we talk about what should be the MCB or the circuit breaker installed at the Q cable level or that capacity, right? We're talking about 20 amps, right? So we are saying, is it okay if you have 15 amps instead of 20 amps, right? Okay, another 5 seconds. All right. So it's majority is correct. Okay, so majority of you have done given the correct answer. So basically, if you see the reason of having 20 amps is basically to have the full capacity. When you have a full capacity of your run circuit, that means you are using 12 IQ7 microinverters. That is when we need. But in case, absolutely you can do that. But what would impact is we'll say that yes, but you will have to limit the number of micros. So because then your calculation goes down. Then you have to calculate based on 15 amps, and then you have to take care of 25% of precautions, right? So that scenario will be taken care. So in case if it is 15 amps, then in that case what will be? So you're automatically reduced. So you'll be calculating for 11.5 amps. So you'll be dividing, 11.5 amps by 1.26. So you can see how many microinverters are coming in, right? So definitely you can do that, but again, that limits your number of microinverters. All right. So in terms of calculation, designing part here, so first you need to calculate the number of micros needed for specified AC system size, then size of microband circuits, don't exceed the max, and then if it is you're designing for the commercial side, then you should also consider the overall size and you have to maintain that closer to 2%. Okay. Now, after this, once we have decided our branch circuit, the next thing is we have mounted our microinverter. We know now how many microinverters I can have, and we also know that what would be the V-rise of movement cable and those things. Now let's also talk about our power line communication, PLC, because that's an important factor, how to get information from our microinverter. So we all know that gateway for our system is Envoy, right? So Envoy is the one which get information from microinverter, and the way it get information is in the form of PLC using ACQ cable. There is no different cabling for communication. So using the same AC cable with a different frequency, it talks to our microinverter. So there are a few important things which we need to consider to make sure that the PLC communication is very reliable, because Envoy has a storage. Even if the network is not there for some time, Envoy can still store the information, and whenever the network is up, Envoy will push the information to the enlightened. But having PLC communication is very important. So always remember, whenever you are setting up the communication, your PLC communication reliability is the first priority, and then the network communication is the second priority. Okay. So when device have been detected by Envoy S, this Envoy, the device will process the Envoy S memory and do not, we don't need to rediscover again. So for the first time when you're doing it, by default, there is no device in the Envoy. So I think when we take a installation and commissioning session, we'll tell you how to do those things. But just to understand here, by default, when you power the Envoy, there is no devices inside it. So you have to run a scan in the installer toolkit. Okay, so you scan the inverter serial numbers, and those serial numbers are stored in the Envoy. So once they are stored, you don't have to do any rescan of that. So those devices information is stored in the Envoy. Okay. Now every time the Envoy will store each device by its performance data every 15 minutes. Okay. So as I mentioned, Envoy is not wasting energy on every time rescanning the devices. So one time when you commission it, it will scan all the devices, and whatever devices scan, it will be in the system. So in case if you are doing replacement or you are adding something, then you have to again run this scan for your installer toolkit. Okay, because after scanning, after commissioning, Envoy only talks those devices which are there in the Envoy memory or Envoy system. Okay, so he keeps polling every 15 minutes from each microinverter which are there inside the Envoy, that okay, this is what I have for you. You give me the information. Okay, so he keeps polling and keeps getting the information from the microinverters. Okay, so this is your power line communication from each microinverters, right? It gets from the AC cable, right, to your Envoy. So that is very important that we should have our PLC design very reliable. Our PLC, the factors which we need to take care during our Okay. Now, so the factors which can really impact the communication, the PLC power line communication, is attenuation, right? So what is it? Attenuation. Attenuation is basically the reduction in the electrical signal. So it could be the distance. If, for example, every time when we say about installation and designing, we make sure that your envoy should be close enough to the microinverter. Okay? So attenuation is basically the reduction in the electrical signals. So if the distance is more, the envoy is located at a longer distance from the microinverters, right? Then the attenuation comes into the picture. The other thing could be the filtering, right? So low signal strength at envoy from the microinverter may be difficult to read or liably detect. Okay? So there is something or something is filtering the signal such as power strips, unreliable connection, or even a circuit being turned off. The other factor is noise. So when you give power to your envoy or the circuit which you have used to give power to the envoy, and if that same circuit is used for other devices which induce noise in the circuit, right? So that also impacts the communication. Very important. So these are the two things which impact the communication. So what is attenuation, as I told? The distance. When you are too far from the system whom you want to talk, that impacts. So if you install your envoy for a distance from the microinverter, that is going to impact your power line communication. That's going to impact your communication, and the chances of data loss will be there. Okay, so sometimes those kind of error pops up in your enlighten that okay, this particular microinverter is not communicating. Okay, so it could be because of something, and automatically after some time it starts. Right, so it may be some noise has been induced or something happens there. Okay, the other thing is these are the filtering things. So one is attenuation, that is distance. The other thing in the line itself, some filtering. You know, these things are there on the circuit. So this could filter your signal, okay, which can lower the signal strength. Then definitely the noise. The high noise floor can be the result of heavy motor load, dimmers, dimmer switches, CFLs, UPS. We use these test controls, plug in those things, home automation system. These are few things that really induce noise in the circuit. So definitely we have these kind of devices in our home or the user have in their home. But that's why it is always recommended to connect the envoy on a separate circuit where we don't have the noise inducing devices in that particular circuit. These are a few examples of noise inducing. So few factors to consider: locating and installing the envoy. So when we say there are typically two ways that your PV system is going to be wired together. Some ways are more advantageous, other than give you flexibility with the communication between envoy and microinverter. The first way is the better solution and the most flexible. So this will show that where your envoy should be. If you have a PV load center and then you have your electrical here, so this PV load center can have the envoy here. So install the envoy in the closest proximity to the solar branch circuit connection with a dedicated envoy circuit and breaker in sub panel. So this scenario is going to be the best way to set up the most effective communication between the envoy and the microinverter. Okay. So by installing a PV load center, it gives you flexibility to isolate the envoy and microinverter from potential noise source coming from the main load center. Okay. So usually that's the reason we give that you should have a PV load center where your envoy should have a separate breaker, dedicated breaker, right? So that you have a separate circuit for envoy. In some situations, what you can see, there's for example here, if you see there is no PV load box. Okay. So in this example, if you see, there's absence of PV load center, and the solar breaker lands directly to your main load center. So if this is the case, what you can do is, if you find it to be the cost prohibitive to install a PV load center, the next best way to install the Envoy is to install a dedicated circuit specifically for the Envoy. So if you are landing this directly to your main, make sure you have a dedicated circuit for the Envoy. Okay? So these are the few things which you need to consider when you design your PLC communication. Make sure that your communication is robust. Okay, this is a quick comparison in terms of what all you need when you have Enphase system for designing or implementation, and when you have a string or a string with optimizer. So I won't hurry to just give a little brief on these things, and it clearly states the benefit of Enphase, but I just want hurry to little bit explain this particular slide so that everybody can understand that.
Yeah, thank you, Arun. So this slide I had compared microinverter technology versus string inverter versus an optimizer solution, which is all the technology advancement solutions available in the market. So the Enphase microinverter technology has an MPPT, multiple in the sense it has every panel has an MPPT. So every inverter makes the panel to operate at its MPPT. Whereas string is that all panels will be connected in series. So what does it mean? The lower panel current will define the string current. So means like if a particular panel due to some shading or due to some a small broken, there are some defect in the panel giving you a current, the rated current less than rated current and close to 50%. So then the string will also be at 50%, will be performing at 50%. And if you see string plus optimizer, it also has then multiple MPPT features. Okay. And coming to the next point, no single point failure. So single point failure. So this is the main thing. Like if an inverter fails, we need to wait for the inverter to get back. In this is mainly predominant in string inverter. Okay. And so that is completely eliminated in Enphase solution. Whereas in optimizer also we have that, it is still a DC architecture. So whenever the inverter is failed, the particular 30 kilowatt or 50 kilowatt or whatever size of the inverter will have the plant shut down. Okay, and passive cooling, there is nothing but a natural cooling. Okay, so I think string inverter has forced cooling. Then noiseless operation. So Enphase is noiseless operation, whereas string inverters are no, and optimizers are also noiseless operation. And coming to the operating life, so almost 25 years equal to the solar panel life, these inverters has an operating life. Whereas string inverters today has 12 years of warranty. Okay, that is the case with the optimizer solution also. And PID, potential induced degradation. So there is no PID effect because PID mainly predominant in the high DC scenarios, okay, more than 80 volt DC scenarios. We do at panel level, so we don't have that PID. Whereas this is there in other two cases. And the hotspot mitigation. So this is like what is that? If you want to address particular issue, you can only do that. No need of completely switching off the circuit. And minimum number of PV panel in a system is, we use one panel to, in the current, this contest we have that 7 plus and 7A, we have one inverter for a panel. And DC design is completely eliminated in our Enphase thing, whereas it is available in other advanced technologies. Okay. And that string sizing, you would have seen the design is very simple. It's a plug and play thing. and whatever the roofs you have any obstructions or shadow-free regions, don't have any constraints, you can install that compared to the other string inverter and string plus optimizer solution. And if you see the tilt and azimuth angle, this okay, so this is also very important in string inverter, because if particular panels, if we keep it in different azimuth, and that becomes weakest spot and that defines the string. So here we don't have that issue at all. And DC components are DC components like nothing but DC junction box, DC DBs is completely eliminated here, whereas this is available in other solutions, string and string plus optimizer. And ours is completely plug and play solution. And high voltage DC on the roof is completely eliminated. Okay. And scalable, absolutely scalable, this one. And modular, this modular in sense you can completely scale up. You can increase the capacity till you want. Okay. This is not available in the other two string and string plus optimizer solutions.
This is the link where you can have the pieces, how to modeling with the, how to, calculation help with the PVCs. Okay, so I have this open. Let me show you. I can quickly show you guys. Let me know. Let me know if you can still see that.
Yes, sir. Able to see. Yeah.
Yeah. So this is basically your, this is basically your, that particular guide where you can use this PVCs to calculate and design things. So in most of the cases not required, but in case if you really want to use it, you want any help from here, then use this. I'm going to share this link with you guys. Not to worry about that. And then
this tech brief, one point. This is available. Hello. Yeah, I don't know if it's audible.